So, what are the keys for graphing this out? I take my zeros of the original function, draw perfectly vertical lines over those, and make it vertical asymptotes. I'm going to find the points where y is equal to 1 or negative 1 and make sure that my reciprocal goes through those points. I'm going to take the y-intercept of my original graph and then take the reciprocal of that. And I can take points where y is equal to 2, then the reciprocal is going to be 1 over 2 or something along those lines. And we're going to keep stretching it out. Now, you're not going to have, because these are not happy points, you're probably not going to have 5 exact coordinate points to go through. So as long as you can get a couple of the key points, especially the invariant points, those are some of the big ones, then we can sort of graph out the approximate shape because it's not going to be perfect. So if I'm given a graph that looks like this, then what I'm going to do is I'm going to say that where the x-intercept occurred, I'm going to draw a perfectly vertical line. You can do a dotted line if you want, a lot of people do. And I know that that's going to be my vertical asymptote where my new graph is going to get closer and closer and closer to it. I know that wherever my original graph was equal to 1 or negative 1, my new graph is going to go through. I know where my reciprocal was about 3, or sorry, my original graph was about 3 here. I'm going to make it approximately 1/3. And then beyond that, all I can really do is I can show that it's getting closer to that asymptote. And show that it's getting closer to the horizontal asymptote where y is equal to 0. What is the y-intercept of the reciprocal graph? If the original one was a y-intercept of 3, the y-intercept is going to equal 1/3. Given that the original graph has the equation y is equal to 3 over 4 bracket x minus 2 squared, then what's my reciprocal one going to be? Y is equal to 1 over 3 over 4 bracket x minus 2 squared. And then when I plug it into my graphing calculator, I get approximately the same thing. All right, I'm going to do the same process for this next one. The graph of a quadratic function is shown. The x-intercepts of the graphs are integers, and the maximum is 2. So what am I going to do? I'm going to start by finding those x-intercepts. I'm going to show my asymptotes. I'm going to find where my original function was equal to either +1 or -1. And I'm going to take where the original maximum was 2 and do a reciprocal where it is 1/2. And then as my original function went up, my reciprocal function is going to go down, and vice versa. And it's going to stretch closer and closer to those asymptotes. Same thing here. As my original function is going up, this one's going down, getting closer to that horizontal asymptote. And as this one goes down, it gets closer to my vertical asymptote. There's my 3 regions. What are the equations for the asymptotes? One is going to be when x is equal to -2, and the other one is going to be when x is equal to +1. The point A and 1/2 lies on the graph of 1 over f of x. What is the value of A? A occurred here at -1/2. The last example is probably the weirdest one. This one looks like a little hill, and we can see that it has no vertical asymptotes, which means that my original function had no x-intercepts. It says that with this, the maximum point of my reciprocal function is -3 and 2. The y-intercept is 1/5. Given that f of x is a quadratic function, sketch the graph of the grid, state the coordinates of the minimum point. So, based on the information we're given, we know that the minimum is going to be at -3 and 1/2, taking the reciprocal of the maximum. We know the y-intercept is going to be at 0 and 5 because the y-intercept of the last one was at 1/5. And we know that there's going to be invariant points where y is equal to positive or -1. This one never has points at -1. So I'm going to graph these points out as best I can. -3 and 1/2. Where this was equal to 1, where this was equal to 1. And this one has a y-intercept at 5, which means that if I went from the center, right 3 and up to 5, then from the center, I'm going to go left 3 and up to 5. And my graph is going to look something like this. it says that f of x can be written in the form y is equal to a bracket x minus p squared plus q. Determine the values of a, p, and q. I'm going to take the coordinates of my vertex, that minimum. I'm going to take the coordinate of my y-intercept. Here's my p, here's my q, here's my x, here's my y. And I'm going to solve it. P is equal to -3. Q is equal to 1/2. And I'm going to say that if 5 is equal to a bracket 0 plus 3 squared plus 1/2, then 4.5, when I subtract 1/2 from each side, is equal to 0 plus 3 is going to be 3, squared is going to be 9a's. If a is equal to 4.5 over 9, they're both divisible by 4.5, and a is equal to 1/2. And there's all my values, a, p, and q. All right, go ahead, get some practice.